good evening, whatever time it might be, wherever you're listening. Thank you all for tuning in and listening to this really interesting conversation we're going to have with Dr. Dane Goodenowe, who is a world expert on the subject of plasmalogen biology and plasmalogen science. I made a post earlier this week about how plasmalogens really might be the most important supplement that most people haven't heard of. And I don't say that lightly. A couple of years ago, I'd never even heard of plasmalogens. I was learning about, medicine and biology through the lens of systems biology, which is a big focus of mine right now, as you guys can appreciate. And through one of the courses I was taking, I discovered Dr. Goodenowe's work. And I think what struck me was just how fundamental plasmalogens are to both health and disease. And as you'll hear today, there are so many different aspects to plasmalogen biology that affect how we function and how we age. That this really strikes me as something that we should be considering fundamentally when we think about how we want to optimize how we age. So Dr. Goodenowe is an extremely accomplished scientist and entrepreneur and inventor. His most recent, he's published, I think, over 80 papers on the subjects of plasmology and biology, and he runs a company called Prodrome Biosciences, which focuses on using plasmalogens as a platform to help improve human health. And honestly, his work speaks for itself if you were to look him up. But I will turn it over to you, Dr. Goodenowe. I hope I did a good job capturing your incredible background, and I'm really looking forward to our conversation today.
Well, thank you very much, Anant. It's a pleasure to be here, and so I'm excited to talk about plasmalogens and human biochemistry and the aging and disease process and how we can understand these underlying causal mechanisms. So
awesome. So I think like a great first question is just to explain in simple terms, like what are plasmalogens exactly and why are they important for health?
So plasmalogens are an essential phospholipid that your body uses to build and maintain the membranes of your body. So the human body is not a bowl of soup. We have structure and we have function, and your heart cells have a certain role to do. Your brain cells have a certain role to do. And so you have 30 trillion cells that make up this human body of ours. And what separates one cell from another is this biological membrane that compartmentalizes one cell from another. And then inside each of your cells, you have what's called subcellular organelles, like where your mitochondria is, or your peroxisomes. Those are also compartmentalized by a membrane that surrounds them. So plasmalogens are a critical component. Plasmalogens are a critical component of that membrane, and they're made by the human body inside. So they're not a dietary molecule. They're an endogenous molecule that your body makes. And one of the biggest characteristics of what we consider an essential human molecule or ingredient is if you take a look at what happens if you don't have them. And so if you take a look at, scurvy, would you have a deficiency of vitamin C, or rickets and vitamin D scenario? So the litmus test of an essential molecule is, can the body survive without it or build something without it? So, and we have genetic diseases of the peroxisome that cause a depletion or a reduction in plasmalogen levels. And these are mortal diseases. So the classic one is called rhizomelic chondrodysplasia punctata. We've known about these diseases since the 70s. And a child that is born with the inability to make plasmalogen molecules in their body will typically die within the first 3 to 5 years, if they're lucky. Okay, if they have a mild case of RCDP, they can live into their teens. So we know from a core genetics perspective, it's an essential molecule that is made by the human body to maintain these membranes. And so later on, when I was studying, I didn't set out to study plasmalogens. I was studying biochemical mechanisms of psychiatric diseases. And one of the areas was dementia. And so with looking at different peoples with different levels of cognitive impairment using advanced high field mass spectrometry, a class of molecules was identified of being depleted in individuals with dementia. And the level of depletion correlated with the severity of the dementia. And then later was shown that it predicted future dementia. And so that was a big find in the sense that, here is an association with an outcome. And then from there, you want to dig deeper into it and say, is this a coincidence or is it causative? And as you dig into the details, you become very clear that it's a causative mechanism, and that there is a depletion in plasmalogens later on. So I've actually filed patents and got issued patents on the plasmalogen deficiency mediated diseases of aging. So, because it's not just dementia then, because from there came virtually all cancers represent with the plasmalogen deficiency. And so you have these genetic diseases that affect children, from birth, and then you have an environmentally associated, life situation that causes a depletion of them later on in life, after the body has fully developed. And once you see a depletion later on in life, you see the association with brain shrinkage, dementia, cancers, and so these age-related diseases. So that's kind of where that comes from.
Well, thank you for that. And I want to double click on something that you said, because I think this is something that I think a lot of people may be wondering, and you alluded to it, which is, can you make the case for why plasmalogen deficiency and depletion is causative rather than being a consequence of aging, right? Because I think a lot of people, might look at, some of the data that's out there and what you've described around, plasmalogens declining over time, and all the different diseases that pop up. How do we know that this is causative and not a consequence of the aging process or of disease?
Well, fundamentally, it's both, right? So plasmalogens are the molecule that your body uses the most to neutralize oxidative stress. So plasmalogens exist inside the membranes of all your cells. And what makes them an antioxidant is this special bond. It's called a vinyl ether bond that your human body makes. It doesn't survive the digestion in your stomach, so your cells have to make it. And the way this physical membrane is structured, with these polar head groups on the outside, these fatty acids on the inside, this vinyl ether bond is positioned right outside or near the membrane surface. And so it's designed to be your first line of attack against hydrogen peroxide, against oxidative stress. And so your body has a natural, so you consume plasmalogens. So plasmalogens aren't some structural molecule that you get when you're born and you keep it forever. Like, you're constantly making these things and replacing them. So when you're under an oxidative stress load from multiple causes, could be COVID, it could be, a concussion, it could be other inflammatory mediated situations. Clearly, so you have mitochondrial dysfunction, for example, something else is not working in your body, you're going to see an excessive degradation of plasmalogens. Now, normally your body is designed to have a pretty good capacity to replenish plasmalogens. That's why it's used as your first line of attack against oxidative stress. So you're supposed to be able to replenish them. So clearly, adverse health circumstances will reduce plasmalogen levels in that regard. So that's an effect of a bad situation in your life. Okay. So then that's the question now is what happens when plasmalogen levels come down low? So then we can study those with cell systems and animal systems, and we can understand how changes in membrane structure and function occur. So we can look and say, okay, doesn't really matter how or why they come down. What happens if they are low? And what happens when they're low is that your body doesn't process amyloid properly. So for the amyloid accumulation in the brain, that is dependent upon the membrane composition. When plasmalogen levels go down, amyloid accumulation goes up. So when we did post-mortem brain studies with Rush University in Chicago, we showed that people that had high plasmalogen levels in their brain had low levels of amyloid. And if we work in the laboratory, if we change, now when I invented plasmalogen precursors in 2006, and we started looking at structure activity, understanding how different plasmalogen molecules interacted and were functionally active in these membranes, we showed that when we increased the plasmalogen levels, specifically the omega-3 plasmalogen levels, we reduced amyloid. And so it is actually controlling the enzyme activity. And the other component is your neurotransmitter release at the synaptic junction. So when neurotransmitters release their neurotransmitters, it's a process when presynaptic neurons release their neurotransmitters, there's a biophysical process called membrane fusion and release. That process requires up to 75% of the membrane ethanolamines to be plasmalogen. And whenever it gets below 75%, you get reduction in synaptic transmission. And post-mortem brain studies show that on average, we're supposed to have about 84% plasmalogen in those membranes. So those are the physical activity things. And then when these children with the plasmalogen deficiencies, they typically have leukodystrophy type issues. They have white matter myelination issues. They have dwarfism, so they get shrinkage, basically like an older person shrinks. They also have reduced muscle density, which is also sarcopenic issues that we have when we get older. And the big issue on the myelination for, say, autism and multiple sclerosis, the myelination process contains a separate type of plasmalogen. And so when we do other types of plasmalogen depletion interventions or disease models like Cooperzone for demyelination, it selectively depletes plasmalogens and it causes the myelin sheath. So we know very clearly that so reverse cholesterol transport is heavily developed. So we look at that versus cancer and membrane structure. So it doesn't really matter why or how the plasmalogens become depleted. Once they become depleted, that membrane structure is no longer doing its job properly. So that's where it becomes clearly a causative function at that point in time.
Got it. Well, very, very well explained. Just to kind of take that to the next level, right? So if we were to expect, from a first principles biological perspective, right? If plasmalogens were causative in some fashion, as you suggest, to human disease, we would expect that repleting plasmalogens in certain disease states we would expect to see a benefit, right? So I think hear from you, like what clinical evidence do we have, or what evidence can you point to around, hey, in these scenarios, when we restore plasmalogen levels or replete them, we see clinical benefit?
So starting with the animal models, so if we give animals plasmalogen precursors and then hit them with a toxin like MPTP that depletes dopamine neurons and causes Parkinson's, we can prevent Parkinson's. So plasmalogen precursors completely prevent Parkinson's in Parkinson models. And then if we have a fully Parkinsonian monkey, for example, that has L-DOPA-induced dyskinesias associated with Parkinson's, and we treat those individuals with plasmalogens, okay, the plasmalogen level correlates with the reduction in L-DOPA-induced dyskinesias. So clearly from a disease model. If we do a demyelination study, we can prevent the demyelination with the plasmalogen precursors. Now in human studies, okay, there are not huge, large randomized controlled trials in plasmalogen therapy in humans at this point in time. We did a clinical trial with Dr. Jordan in Santa Monica, where we looked at 22 individuals with cognitive impairment, broad range from mild cognitive impairment, mild to moderate, which was very significant cognitive impairment. And they also had mobility issues. And we tracked their mobility. So we wanted to reproduce the animal studies by providing a dose-dependent increase in plasmalogen precursors to show that we could actually increase plasmalogen levels. And we did exactly what we did in our animal studies. And so, but what we found was we had a statistically significant improvement in cognition. And actually 75%, like 3 out of the 4 people who had moderate dementia, which is like unambiguous dementia, improved an entire score on the clinical dementia rating within 4 months. Okay, and the trial was not designed for that. And 50% of the individuals with mild had that situation. More than that, even had improvement in their sit-stand rates. And so that's where we find, anecdotally, in our experience with our clients, our improvement with cognition is virtually ubiquitous. We have individuals that have been literally in conservatorship that took back their companies. We have individuals that were going into hospice for long-term, for death, and they're now taking their grandchildren to soccer practice. So we do know unambiguously that we can improve health in our clients. I have individuals so we know that we're seeing it, and our doctor network understands that as well. And this is also why So we're starting 2 large observational trials. We have a big observational program in Moose Jaw, Saskatchewan, involving thousands of individuals. And about a month ago now, I announced that we formed a new drug company called Dr. Goodenowe Dietary Therapeutics, which is going to take the omega-3 plasmalogen precursor called Goodenowe through a full IND FDA path for actual label, the ability to label this molecule as useful for the treatment in dementia, for example. So that's one of the challenges with the nutritional world, is the type of clinical trials that we do to validate this. So there's observational epidemiological work, which we're going to be doing, and we do this large blood work that we do, and we can correlate. The other thing we found in that clinical trial with Dr. Jordan is that there was a correlation between increased plasmalogen levels, decreased malondialdehyde levels. It increased our catalase levels, so malondialdehyde is the critical oxidative stress marker of oxidized phospholipids, for example. So it comes from oxidized arachidonic acid. And catalase, which is your key enzyme for neutralizing hydrogen peroxide, also is a critical molecule that decreases with age, and it's actually found in the peroxisomes. So that increased as we gave people plasmalogens. So we know there's a pharmacodynamic situation. When we add these plasmalogens into individuals, their blood chemistry changes. Okay, there's an unambiguous change in blood chemistry, and symptomatically we see those benefits. And so, of course, like anything else, it's a critical. So what's interesting with the plasmalogen story is it's additive to all the other knowledge that we've applied to this date. And people do mitochondrial optimization. We do proper, reducing your triglycerides and improving all the other stuff that we've done from integrated medicine are still valid. But we haven't, even when you do all those things, we still see brain shrinkage. And now we have advanced MRI technology where we can track individuals. So all of the elite doctors in the Prodrome network, they're getting advanced MRI. We're tracking their brain recovery. I'm obviously, client number one in that regard, and I've had post-concussive syndrome since I was 8 years old. So I had areas that I didn't know were affected in my brain, and I've been able to restore brain structure and function. So we now have unambiguous MRI information, and this is very highly reproducible across our clients, that we can restore brain thickness, like the cortical thickness levels, increase fiber dynamics. I have a woman who's been blind for 32 years with multiple sclerosis who can now see out of her blind eye, and we can map the recovery of her vision with advanced MRI. And so she was just actually at our center a few weeks ago. It was quite amazing. So she can now, and her eye is continuing to get better. This is, she's been blind since the 90s, and now she actually has vision, and her drop foot has virtually disappeared. She's got energy. She travels around the world. It's quite amazing. I got an ALS client in Australia right now. 2 years later, he went to India for 2 months just to go touring, and so he's continuing to get better. Okay, on our program. So this integrated health model, where we basically ignore disease, restore health, and we just get better and better at it. And then once I tell people we're the boring company, like we're the fertilizer company. We're here just to make sure that the system is performing at the original operating specifications. And then we can add on top of it, like you have to put your body into the right positive environment afterwards. We have a program in autism called NeuroSupport. We have almost over 200 families now we support. And they all go into this Engage program, and they communicate the results. We have a 95% positive outcome rate in autism, 95%. And this is self-report from the parents of autistic children. And so we provide this, highly subsidized program for families with autism. And this is the omega-9 plasmalogen precursor. And then later on, after a couple of months, they start putting the omega-3 in. So we know, we're a company that exists entirely based upon consumer success. If our doctors and our practitioners and our patients aren't feeling an effect, I wouldn't be here talking to you right now. So that's what and then our job is to build systematic science, which is the clinical trial infrastructure in Temecula, California, and Moose Jaw, Saskatchewan, so that we can really start showing at the epidemiological level that we can modify the incidence and prevalence of certain diseases going forward.
Well, thank you for sharing that. I mean, there's so much to unpack there that I was thinking about. Let me just start with one very practical one,
Sure.
which is, you've talked about two different types of plasmalogens which you offer, omega-3 and omega-9, and these correspond to two different products. And actually, just as a note, is neuro no longer going to be available now as you put that into an IND, or how does that work? But my question is, explain the difference between these two types of plasmalogens, when they should be used, and that sort of thing.
See, this was actually the critical component of the invention and the patents relating to plasmalogen precursors. Because in human breast milk, you have primarily the omega-9 plasmalogen precursor, and it's really fundamentally designed for improving the myelination of the developing child. When children are born, they're actually born plasmalogen deficient, and their blood levels of plasmalogens don't reach normal levels till between 6 and 12 months of age. And so this first 6 months of life, breastfeeding is critical to help supplement the developing baby's brain development, okay? And so the omega-9 version is designed specifically for this focused, concentrated aspect to go into the myelination. It reduces inflammation. It reduces I tell people that it's a calming, anti-inflammatory, smoothing out molecule. Incredible for gut activity, gut issues. But it's the tuning molecule. It's not activating. Okay, the omega-3 version, that's the one that is involved in the synaptic cleft, that's involved in reverse cholesterol transport, that's the activation molecule. And I always tell people the two molecules can be thought of as two dials on an old radio. Okay, and the one dial is tuning the station to, tuning the radio to the station. And you'll notice if you're out of tune, if you're not quite on the station and it's a bunch of static noise coming through, well, if you keep the volume low, often you can hear the music behind the static. Okay, that is an ADHD person. That is an autism person. That's a COVID person. That's someone with post-chemo brain fog, for example. So virtually everyone, all women with post-breast cancer chemo have brain fog. That's static. That means there's a bunch of noise, a bunch of neurological noise going on. And you can't turn the volume up when you're full of static. And so glia is designed to improve the myelination, allow the signaling that happens with those copper wires that are innervating through your whole body, those signals to be clean and clear. And so then neuro turns up the volume. So once you've actually tuned the station to the radio, okay, now you can crank the volume up. You can blast that sound, okay? And so the omega-3 version is for volume. And so the critical component of the invention of the plasmalogen precursors was the structure-activity relationships and the ability to supply a particular type of plasmalogen precursor at a particular time for a particular purpose. And so we typically use the glia or the omega-9 plasmalogen at night. It's calming, it helps sleep, it's a rebuilding molecule. And then during the day, you use the omega-3 and it's cognitively stimulating. It makes lights brighter, your brain sharper, it improves, neuromuscular function. It was actually really an interesting anecdotal story. Okay, so I take high levels of plasmalogens for a couple of years now, right? And I've been noticing that my physical strength and my recovery strength and everything is much better than it ever was in my 20s and 30s, right? So we finally got our advanced blood work done here. We do, because other doctors in our network are experts in hormones and all that kind of stuff. But we're getting the hormone panel and everything ready for our doctors in the lab right now. And so I got my blood tested. So, I'm 57, my testosterone level is at 850. And I don't take any kind of, hormone therapies. And so we do know that because it stimulates the hypothalamic pituitary axis. So we're very interested in we've seen other anecdotal stories where men pre-plasmalogen, supplementation had big jumps in their testosterone levels. And so I think this supplementation of our individual structure, because it's improving the neurological signaling that actually drives a lot of our other regulatory systems. So we're still at the infancy of learning all of the downstream effects. We know all the negatives. The negatives are easy to find out because the plasmalogen deficiencies and associations with cancer, neurological diseases, like ALS has a plasmalogen deficiency. Parkinson's, plasmalogen deficiency. Dementia, Parkinson's deficiency. Virtually every single cancer has a plasmalogen deficiency. If you have a COVID infection, your plasmalogen is going to go down. Okay, so that's an unambiguous story, right? We can see that negative side. What we haven't really figured out yet completely is when we add these molecules in and we get to higher than normal levels over sustained periods of time, what type of enhanced human function can we create? And for me, reducing the aging of my brain was a critical thing because I had my vision and my headaches. I thought I was performing at a high level at 52, 53. And I didn't know that I was still suffering from a concussive injury from 8 years old. And I had cortical thinning in my occipital cortex. I thought I was going to be a control person. And so I've been able to restore all those brain structures and function and quantitatively, reduce the aging of my brain by at least 15 years now. And this is what we want to basically be able to provide, this type of really hard science, objective measurements in the blood, objective measurements in the brain, okay? And obviously I focus a lot neurologically because I think as your brain goes, you go. Like we focus a lot on our peripheral, but you need to see what's going on behind that skull of ours, because that shrinkage of the brain is really scary. It's scary to see all these super high functioning individuals, and they're doing everything right. They're smart. They understand the chemistry. They understand health and physiology, and their brains are still shrinking. And we cannot live a long life if we can't stop the shrinkage of the brain.
Well, I think first off, I think that makes a lot of sense. I think let me just shift gears now to the story around cancer, because I think intuitively to me, and I'm sure to the audience, the idea of how plasmalogen repletion and supplementation, augmentation can support cognition and avoid neurodegenerative disease, I think intuitively makes sense. You've talked about the role that plasmalogens play in myelination. You've talked about the role they play in oxidative stress and mitigating against that. I think we can intuitively appreciate how in those conditions, having more of this biological resource around can be helpful. But as you can appreciate, cancer biology is more complicated, right? And with cancer biology, we know that sometimes things that, for example, perform antioxidant functions, right? Or provide structural support, right? Like sometimes a cancer cell, we don't want it to be able to detoxify antioxidants or have all these structural components, because that will enable it to go out of control. So I'm curious how, and I'm sure you've probably heard this criticism too, that like, hey, could plasmalogens, given their role, be cancer promoting? So I'm curious, how do you think about that as far as plasmalogens and cancer biology go?
So I've studied cancer with extreme depth. I probably have more blood analysis work in cancer than even in neurological diseases. I have Health Canada approved diagnostic tests for colon cancer, pancreatic cancer. Ran a 6,000 subject colonoscopy trial, understanding prediction of which polyps convert into cancers, and so on and so forth. So cancer biology is something I actually know in deep detail. And it's kind of a bit of a pet peeve of mine. So cancer biology is actually not that complicated. All cancers are fundamentally the same. What makes them a little bit different is what cell type it occurs in. All cancers are fundamentally a disease of mitochondrial dysfunction. And you get what's called extra mitochondrial ATP production versus intra mitochondrial ATP production. And what that does is it puts the cell in a constant fed state. So I do a full detailed lecture. I use breast cancer as an example, and I use the BRCA mutation as an example, as a clear model of understanding cancer biology. And I published a study in Japan that we did with 2 cohorts of women with breast cancer. So what happens then is this fundamental, the mitochondrial dysfunction occurs. This is why we're seeing the turbo cancers, okay, that we're seeing with COVID, for example. So COVID is this mitochondrial toxin. And so we've knocked down 20-30% of human mitochondrial function. And so we've added this risk factor that's loaded onto our format. So what happens then is when your body's in the fed state, it's catabolic, it's not anabolic. So which means you're not building things. So when you, and people, this switch between your fed state and the fasting state is not trivial. It's very, very important to understand, because it's when you're in the fasting state that your peroxisomes work. So the reason why you do intermittent fasting, okay, resistance training, all those things that lower your triglycerides and increase your HDL levels, those are supporting your anabolic fasting state of the human body. And when you eat a meal, okay, your body is storing energy in your fat cells. And so it's in the process of taking sugar, fat, protein, and it's converting it into storage molecules called triglycerides. And it's sending them to your fat cells for later. Okay, so you're not building anything right now. You're at the gas station and you're just filling up the tanks, fundamentally, for this period of time. It's like your iPhone is unplugged and you're out running around, you're not charging it, you're just using it. That's what's going on in your fed state. And so when that happens, your peroxisomes, okay, so when people think about fibrates or peroxisomal stimulation for reducing, for reducing triglycerides, increasing muscle mass, for example, it's a critical component. Peroxisomes are shut down when you're in the fed state. Plasmalogens are made in the peroxisomes. Okay, so plasmalogens are made in the peroxisomes. Cholesterol is made in the peroxisomes, the critical components of cholesterol metabolism. So what happens with cancer is you get in this chronic fed state, and your body doesn't make plasmalogens because the triglycerides aren't being, it's using sugar instead of free fatty acids. So when you go into the fasting state, which is why going into a keto state is always pro-cancer, people talk about lowering sugar, but it's not really about lowering sugar, it's about switching the body to fatty acid metabolism. There's a couple of cells in your body that virtually never, ever get cancer. Okay, it's almost impossible to find heart cancer. Muscle cancer is virtually non-existent. It can happen from a metastasis perspective, but it's virtually a completely non-existent state. And the reason for it is that those two types of cells rely almost entirely on fatty acid metabolism. They don't use any sugar for metabolism. So when you're in the fasting state, your adipose cells are releasing free fatty acids into your blood supply. And the free fatty acids come into your cells, and your mitochondria use the fatty acids to create ATP and energy. Your peroxisomes use some of these fatty acids to build membranes and build fat and build things. And so what happens in cancer, sorry for this long answer. So our cancer program is really focused on pushing the system back into an intramitochondrial ATP production. And there's biochemical mechanisms, and then there's other support drugs that you can use. Like ivermectin and rapamycin. These are molecules that are the AMPK agonists, for example. Those are things that really improve. So this process. So people get caught up in a given, here's pancreatic cancer, here's ovarian cancer, but the difference between those is just how does this cellular dysfunction manifest differently in a pancreatic cell versus an ovarian cell. Okay, so what you're doing when you're comparing these different cancers, you're really not comparing the difference of this cancer being different than another cancer. It's that this cancer in this cell is a different cancer, and this cancer in this cell manifests differently. And if you have any kind of genetic predisposition that follows one that preferentially affects one cell type, like BRCA, for example, okay, which affects primarily breast cells, and ovarian cells. That's kind of where it goes from cancer. So even historically, when people look at alkyl glycerols, they reduce metastasis, they reduce cancer. They're linked to lower rates of cancer in different populations that take, crude alkyl glycerols that are like from shark liver oil, for example. You can get some of them in there. So anyway, so that's a long diatribe about cancer. We can spend all day on cancer. I'm very passionate about it. And so, yeah, so preventing cancer And getting your body into a low cancer risk scenario is really about making sure your mitochondrial biochemical systems are working properly.
So it seems like, from what you just said, the plasmalogen piece is a key component of restoring the system's biology, so to speak, of a cancerous cell. And I think what you pointed out was that, when you have this extra mitochondrial, or like, energy production, that you put yourself into this state of dysfunction that perpetuates. And I guess, just to double click.
Oh, the key part that I forgot to mention is one of
Yeah,
the
go
core
ahead.
components of cancer biology is that we get accumulation of cholesterol in the membrane. So cholesterol clearance gets disrupted. Okay, so reverse cholesterol transport. So HDL, low HDL levels, low cholesterol are all linked to high cancer rates. Okay, so what the omega-3 plasmalogen precursor is powerful at, especially in combination with phosphatidylcholine. Okay, phosphatidylcholine is another critical thing regarding cancer. Virtually all liver and pancreatic cancers are caused by choline deficiency. Period. That's why phosphatidylcholine levels are measured in the bioscan and the proton scan blood test, because it's one of the most underappreciated and missed. Steve Jobs, I can guarantee you, he died because he had a phosphatidylcholine deficiency. Absolutely. Okay. I've never seen a pancreatic cancer person in hundreds and hundreds of pancreatic cancer blood samples that I've never seen one that had normal phosphatidylcholine levels. Okay, so because that drives your reverse cholesterol transport mechanism. And so if you can't, and so the HDL system is what regulates the cholesterol levels. And when the cholesterol levels get modified in the membrane, it opens it up to glucose. Glucose just comes pouring in. Okay, and it forces the cell into a glucose pro environment. This is why these membrane structures, they're kind of complicated, so people kind of just don't want to dig into it too much. They'd rather get a simple answer with a particular drug, but they regulate how the system is working. And so it's the cholesterol system that's really critically affected by this plasmalogen deficiency, because it screws up the cholesterol transport mechanism. HDL cholesterol transport is dependent upon plasmalogens in the membrane. Okay, absolutely. So we published a big paper on cholesterol regulation, and it's the omega-3 plasmalogen precursor. And this is why people with high levels of DHA plasmalogens, it neutralizes, it's the antidote to the ApoE4 genotype. So ApoE4 carriers that have high levels of omega-3 plasmalogens have no increased risk of Alzheimer's disease. That is a 1,200 subject trial I did with Rush University, clearly unambiguously showed, and we did this in post-mortem work as well, that the ApoE4 effect on Alzheimer's is related to the reverse cholesterol transport problem in the brain, because in the brain we don't have LDL and HDL. We don't have apolipoprotein B or apolipoprotein A. All we have is apolipoprotein E in the brain. And so apolipoprotein E is ambidextrous. And it's only one component of this E4 mutation, okay, which removes this disulfide bridge capability that messes up the ability to do reverse cholesterol transport. So ApoE4 carriers will typically have higher levels of cholesterol, total cholesterol, and sometimes a little bit lower levels of HDL, because they're kind of cholesterol savers in their cells. So anyways, another diatribe. Sorry about that.
No, I mean, I think hopefully everyone listening now can appreciate what a wealth of knowledge Dr. Goodenowe has. It's certainly one thing that, as somebody who's passionate about understanding things through the lens of pathways and mechanisms, it was one of the reasons I was drawn to your work. And so I really appreciate the detail. But just to kind of I want to kind of crystallize this and kind of frame it in a way that maybe people in the audience can. Oh, we lost you there for 1 second.
Or I lost you. Either way. So
yeah. Okay. Well, I was going to say, just to kind of crystallize this so that people can conceptualize it. It seems like at a high level, these plasmalogens play two very essential roles. One is, they help to support the fluidity and proper function of the membrane. And the second is that they play a crucial role in kind of getting rid of reactive oxygen species. And then as a result of that, you can have healthier function of various cellular processes. And when we have disease, you have dysfunction that directly or indirectly implicates plasmalogen deficiency. And by bringing plasmalogens back into balance, we can help to restore better cellular balance. Would that be kind of like a fair and accurate way to capture the importance of this?
Absolutely. And we just look at the simple stuff. Okay, we often we get way in the deeds way into the weeds when it comes to longevity. But there's a few basics that really drive human longevity. Okay, low triglyceride levels, which means your metabolic syndrome is in a good place. High HDL, good levels of cholesterol. These are really strong predictors of long-term health. The other big one is skeletal muscle mass. Okay, maintaining skeletal muscle mass, not your BMI, actual muscle mass. And if you maintain skeletal muscle mass and you keep your oxidative stress levels low, okay. We just did a big lecture on this. Basically, healthy fat people live the longest. Okay, and it's the because when you carry some weight around you actually have muscle to carry it. And it's the biggest issue we have with this with GLP-1s and things where people are losing muscle. They're losing muscle mass. And so you have to really preserve your muscle mass. And the reason for it is your muscles are one of the highest concentrations of peroxisomes in your body. And if you have good muscle mass, chances are you have good plasmalogen levels. So there's a little trifecta there. Okay, typically speaking, if you have nice low triglycerides, healthy levels of cholesterol, okay, you're going to typically have good levels of plasmalogens because those things kind of go hand in hand. And especially if you have good insulin sensitivity type of thing. So these basics all make sense. So if those things are working, your chances are your plasmalogens are in a decent range. Now, whether they're in a large savings account range, kind of like a vitamin D story, is another story. So because your body's lazy, it's only going to do what you force it to do, right? It's not going to make more than what it needs at one point in time. And so same thing with working out. I tell people we want to create a biochemical reserve capacity. The same way you create a reserve capacity to everything else in your life. I work out to build muscle mass, not because I need to be able to lift 50, 60-pound weights while I'm sitting here moving my mouse around on my computer. In my everyday, there's nothing in my everyday life that requires me to lift heavy weights. But I create an artificial environment. I trick my body into thinking that it actually lives in a world that it needs to lift certain weights. And so it adapts to that. And then if you do cardiovascular training, if you go running or you're increasing your endurance, again, you're tricking your body to thinking that it needs to perform in an environment, in a more extreme environment than you are actually living in. Because everyone's everyday life, you don't need to be running 4 miles, right? And you don't need to have that oxygen capacity. And your body will not create that capacity unless you create a reason for it to do that. At the biochemical level, it's the same way. So if you think, if I just eat properly, okay, that I'm going to create biochemical reserve capacity, you're wrong. Okay, that's just like saying, I'm just going to walk around normally. I'm going to have a nice, normal, non-active lifestyle. Your body's not going to build muscle if you don't do resistance training. Your body's not going to build mitochondrial capacity and oxygen capacity unless you do oxygenation training, which is cardiovascular training. Your body is not going to create biochemical reserve capacity, okay, unless you actually give it strategic biochemical supplementation. And I think sometimes they have this weird view that they think they're going to somehow have a magic diet, and in my philosophy, that doesn't work.
Interesting. Yeah, I think that, a lot of what you just said, I think a lot of those things are longevity essentials, resistance training, cardiovascular training. I think where a lot of people get stuck is, what is the role of supplementation and how do we navigate this, seemingly endless universe of supplements, right? And so I'm curious to hear from you, right? Like certainly I think you've made the case for plasmalogens being a important thing for most people to supplement. What are some other tools that you think are rise to that level of importance that deserve consideration for most people when it comes to supplementation for healthy aging.
Absolutely. So, and you should think of supplementation not like food. It is food, but it is enhanced food. And you're trying to get a pharmacodynamic response. So your classic vitamins are 20-30% of the population still is riboflavin deficient. Okay, niacin deficiency is rampant. So good old-fashioned thiamine, riboflavin, niacin, these are B1, 2, and 3 for a reason. They're critical, and we don't get enough of them. So those should be part of your routine. Maintaining your glutathione levels, good old-fashioned N-acetylcysteine. And remember, you're doing something that you're going to do for multiple years on end. This is not a fix. So the other thing is not saying, oh, I'm going to go on a supplement protocol for 2 months to fix some disease, and then I don't have to do it again. No, this is like water. You take it, you need it all the time. So your B vitamins are critical. Your methyltransfer, so the mitochondrial function of your body, which is critical, right? So inside the mitochondria, those 3 B vitamins are critical. Then you need your alpha lipoic acid, which supports your pyruvate dehydrogenase, coenzyme Q10. You need N-acetylcysteine. That's the only way you can get glutathione inside your mitochondria. Carnitine is a good, very important molecule for improving palmitic acid movement in and out. So that basic cocktail there is critical. Your minerals, okay, you need to be on proper minerals: magnesium, selenium, zinc. Okay, those are common molecules that you can lose. Simple as easy, cheap as dirt. Make sure you're on some minerals. Then the methyltransferase system is another big weak link. All the neurofibrillary tangles that occur with aging caused by methyltransferase insufficiency in the brain. So methyl B12, methylfolate, I still promote, B6, but the big ones are creatine and phosphatidylcholine for methyltransferase. So if anyone is trying to figure out, oh, my homocysteine levels is still hanging around 12 and I've done everything right and I can't get them down, you put good old-fashioned creatine. Creatine, cheap as dirt, 4 or 5 grams a day. It'll help lower your homocysteine levels. And phosphatidylcholine, animal-based phosphatidylcholine. It's a critical component for reverse cholesterol transport. It's the only kind of molecule that gets into the brain. So this is a pretty big list, right? Now, if you're a guy like you and I, and we want to actually maintain muscle mass as we get older, well, you need to have a leucine-enriched diet. Okay, like it's not just protein. Okay, you need your proteins, but you need to make a protein that has good sulfur amino acids in it, so like the whey proteins and things like that. But sometimes if you're on a plant-based diet, you have to be really careful that you're getting certain other additional nutrition. But leucine enrichment, critical for maintaining. Leucine in combination with your niacin will help you build muscle late in life. And so preventing the muscle wasting concept. So these are all, so I thought, well, mitochondria, membranes, methyltransferase system, those are 3 biggies. And if you take care of those core systems, and then you remember I told you have 30 trillion cells in your body. And when you take a supplement, it's not like taking, like when you take, if it's part of your food supply, it kind of trickles into your body through your digestion process, right? But when you take a 100 milligram pill of riboflavin, okay, or 100 milligram of thiamine, okay, or riboflavin 5-phosphate, depending what you like, okay, you're going to get this peak, and it's going to push it into your cells, okay, and your cells are going to hold it, and then it's going to kind of leak out over time, okay. So there's a pharmacokinetic response of these pulsed supplements into your body. And so this is what we do. This is what I consider biochemical engineering, and why we're the fertilizer company. Like we're basically making wine, and your body is the vessel. And we're saying, okay, how do I make, what are the ingredients and what compositions do I need to make sure that this system is running properly? And then the regular food supply is what you want to do. So yeah, so these are critical, and these are basic stuff. And same thing with vitamin C. A couple grams of vitamin C is critical, especially if your uric acid levels are low. You want to make sure you keep your vitamin C levels up. And you pick a program, and as you look at a multifaceted program like that, then and you stick with it for long periods of time, we're not talking about quick fixes. We're talking about restoring and creating a new equilibrium in your system that is sustainable over time. So it's not, there's no magic molecule. There's no one molecule that's magic. So what the plasmalogen precursors do is that they make all the rest of this work better. It's one of the missing links because it hasn't been available. Like we can do all these other things, and if you're plasmalogen, it's like I tell people, you're baking a cake for Thanksgiving and you got 20 ingredients, but if you only have half the flour you need, you're only making half a cake. And so like you can have everything. So you need all the core ingredients in for the recipe to work. You can't just have 8 out of 10 of them, because the 2 that you're missing will determine how much cake you make. And this is what's going on with the human brain biochemistry, and why we're reversing brain aging is because this plasmalogen precursor has been that rate limiting molecule. We have all this other advanced knowledge that is all valid. Like all this stuff that we talk about is incredibly valid, but it can't perform if it doesn't have plasmalogen precursors as well. And so that's kind of what. So it's a long list, and getting it incorporated into your program. And there's other little flavorful things you can add to that list, like ketone esters and so on and so forth. And then you get into more fancy stuff, thinking peptides. So the point is when you're signaling the body. So we're fertilizer. These are core components of the molecule. There's 2 components of your body. There's the carpenter and there's the plywood. Your mitochondria, peroxisomes, these are carpenters. They're the things that actually go out and do things. But you need to have, so they need to be working. You can't have a carpenter with a broken arm and expect him to build you a house. And likewise, you can't build a house if he has to go out in the forest and cut trees down. So what we want to do is we want to make sure the carpenter's working, and we want to provide that carpenter with pre-made material. Here you go. Here's your phosphocholine. Here's your plasmalogen. Go build me a house. Okay, and so this, and then when you put those 2 components together, it'll rebuild your membranes. Like your body's designed to work. These cells want to do their job. Like the oligodendrocytes, the only thing they want to do in life, they grew up saying, I like to make membranes. I like to make myelin. Help me make myelin. And so what I try to get people is to get thinking like a cell. If I'm a heart cell, what do I want to do? Okay, I want to contract. I want to have high mitochondrial capacity. I got to, I'm being fed in the diastolic phase and not the systolic phase, and blah, blah, blah. So put your head in that cell and say, okay, how do I help you do your job? What do you need? What do you need? What can I give you? And then you can stimulate it with a peptide or exosome or stem cells. Okay, but those types of interventions, you're asking the body to do something. Okay, but the body has to do what you ask it to do. Like I can't ask it to do something if it doesn't have the physical capability to do what I'm asking, then I'm not going to get the outcome I want. Which is why we're the boring guys. We're just saying we're the fertilizer company. We're here just to make sure everything is plump and full, and then you go and take this operating system and go to the gym, go to school, find out new things you want to do, and decide where you want to push your limits from there.
Love it. Let me ask you 2 questions. They're separate, but I want to make sure we get to these before we conclude here. The first was, in the list of things that you mentioned, I did not hear you mention omega-3 fatty acids, like triglyceride-based omega-3s, which are typically things that a lot of people think of as mainstays. And I think what I want to also have you do is explain, because I think people are hearing you say omega-3 plasmalogens. They also hear about these other omega-3s. So maybe you can do a quick primer on the difference. And then, do we need to have both, right? I think I would appreciate that. And then the second is just if you can share with us a couple of basic protocols around how to leverage plasmalogens as part of a healthy aging, healthy longevity-based protocol.
Sure. The omega-3, omega-9 dietary supplementation, is critical. They're very valuable. So first of all, omega-9 is not an essential. Your body will make oleic acid, for example. But your body uses 2 polyunsaturates for membrane fluidity. And at the membrane level, they're almost identical. Okay. One is arachidonic acid, which is built from linoleic acid, omega-6. And the other one is DHA, which is your omega-3 polyunsaturated. And those are the things that create membrane fluidity. So the sources of those, so you don't really need to worry about getting arachidonic acid because your body will make it very quickly from linoleic acid. And when it comes to the membranes of your body, linoleic acid, which is omega-6, is the ambidextrous molecule. It's found in membranes, and it's found as a precursor to arachidonic acid. On the omega-3 side, people talk about flax, like alpha-linolenic acid, right, as a precursor to DHA. But your body virtually does not use linolenic acid at all. It only uses the final omega-3. And there's a big process to make it. So it has to go fatty acid elongation, desaturation, a bunch of stuff happens. Then it goes into the peroxisome and it creates DHA. So the making of DHA is actually not trivial. So getting DHA in your diet is important by any mechanism possible. Absolutely. And also DHA itself, not only is it a physical structural molecule in your membranes, it is also a PPAR agonist. So it actually lowers triglyceride levels. So it's very highly reproducible. And the reason why it lowers triglyceride levels is because it's a PPAR agonist. So it's a very valuable molecule. So when you're taking, so the question is, what are the different sources of DHA? So you take an algae oil or fish oil, right? That's triglyceride based. Your body recognizes triglycerides like food because your body makes triglycerides and stores it in your fat cells. So if you take a triglyceride based DHA molecule, you're still getting DHA, which is good for you, okay? But that's not a plasmalogen. So there's two components. There's a backbone, which is either this glycerol backbone, or you have a plasmalogen backbone. And you can think of these molecules like a power strip that has 3 plugins, right? Well, plasmalogens, the top plugin, you can't unplug. It's a fused molecule. It's an ether bond. And your body makes that molecule. And so that's the part that gets made in the peroxisomes. So the SN1, the SN2 and SN3 positions contain these fatty acids. So the plasmalogen precursors are molecules that have the plasmalogen backbone, so they're not triglycerides, and they get metabolized differently in the body. So when they get absorbed, they go directly into your muscles, into your brain, because your body doesn't recognize it as food, so to speak. Okay, so the alkyl acylglycerol goes into your cells, and then your cells take that molecule and convert it into plasmalogens, the final phospholipids. And that's why they're very, very different. So the alkyl glycerol in human breast milk is very different than olive oil. It's not the same molecule at all. So you need two components. You want to get the right fatty acids, which are important, and you can get them from a variety of sources. The plasmalogen backbone is uniquely either made in the human body, it's available in good form in human breast milk, it's available in a kind of a really diverse, diluted form in shark liver oil, or you can get it in pure form with either the omega-9 or omega-3 versions of our plasmalogen precursor supplementation. And that goes in. The last thing I want to leave you all with is, I think, as practitioners and experts in human physiology and in integrative medicine, you do a lot of blood testing. And when we're blood testing for biochemistry, it's the opposite of blood testing for drugs. So when you take a drug, I take a Prozac and I want to measure a flow, or you're giving a patient, say, valproic acid for mood stabilizing, and you say, okay, what's my therapeutic window for valproic acid? Well, when you give a person a drug, you're looking at the level in the blood that you're getting from the diet that you're going to push into the cells. Okay, so you're looking at how does the blood level go into the cells. That's not how human biochemistry works. It's the other way around. So when we're measuring plasmalogens and cholesterols and triglycerides, what you're doing is you're measuring what's coming out of the cells. Okay, it's a measure of cellular health. It's the opposite of what we think of when we talk about drug pharmacokinetics. So biochemical equilibrium is not, so when you have high levels of plasmalogens in your blood, those plasmalogens are not going into your brain. None of the plasmalogens in your blood supply go across the blood-brain barrier. Virtually none of those plasmalogens are actually going into your cells. What you're measuring is what's coming out of your cells. So if you have good levels of plasmalogens, it means your cells are healthy. They're making plasmalogens and they're exporting the excess. Okay. If you have healthy levels of cholesterol, that means that your cells are actually healthy. They're making adequate levels of their own cholesterol. The cholesterol in your blood is not being pushed into your cells. The cholesterol in your blood is coming out of your cells. Okay. Then your liver is dealing with it. So we have to look at it slightly differently. Sometimes we look at these blood levels a little bit differently. So when we're looking at these regulation, like biochemical optimization, We're here to think about, are the cells in my body healthy? Okay, and how do I know if they're healthy or not? I'm not trying to push things into them, other than what I just mentioned earlier with the pharmacokinetic pulse of supplements. So hopefully you've answered that dichotomy of why a plasmalogen precursor is very different. So yes, so if you take the omega-3 plasmalogen precursor that we manufacture, you do not need an omega-3 supplement. It is the highest purity omega-3 on the planet. I'll just give you a short answer of how we make it. So we take high purity algae oil, and even the highest purity, if you go on supermarket shelves, I don't care what purity you get, oh, here's super DHA and it's got 500 milligrams of DHA. There's chances are it's only 30 to 40% actual DHA in total. So we take the highest purity DHA triglyceride algae oil, and it's about 40% DHA. We saponify it to get all the fatty acids off the glycerol backbone. Then we go through an advanced purification process. We remove all the other fatty acids. So now we get a pure form of omega-3. It's 95% omega-3. Okay, it's virtually pure omega-3. And then we take that pure fatty acid mixture and we attach it to a plasmalogen backbone. So when you're taking the omega-3 plasmalogen precursor, you're taking pure DHA. Okay, it's like pharmaceutical grade pure DHA on a plasmalogen backbone, and that's why you get this hit with it. And the omega-9 is the same way. So we use a high oleic acid sunflower oil, which is not equivalent to a seed oil, people. Okay, it's not. A high oleic acid sunflower oil has a high flash point. The danger of seed oils is what position the fatty acid is on the glycerol backbone. It's a deeper conversation. So a high oleic acid sunflower, high oleic acid oil, it doesn't have the omega-6 problem that the other seed oils have. Read that as it may. We still strip it off the glycerol backbone. We just use it as a source of oleic acid. So we get this high purity, pure oleic acid fatty acid mixture, and then we put it on the plasmalogen backbone. So the omega-9 version, the reason why you get this such a beautiful, pure, calming feeling from it is you're getting a pure dose of oleic acid going right into your brain, right into your cells, and it's a very calming from a neurological perspective. So the purity, the concentration of these products are as important, if not more important, than the total composition of them. So the total amount, like even if I get an olive oil, if you actually look at the composition of olive oil, it's only going to be, 40, 50, 60% oleic acid. The rest is going to have everything else in it as well. So it's not a pure omega. It has other good stuff in it, or avocado oil, which are, those are two great oils. People clearly shouldn't shy away from. They're great oils, and they're not seed oils, right? Because you're dealing with the pulp, right? Like you're not actually using the avocado seed, and you're not actually using the olive seed. You're actually getting an extract of the pulp, right? So it's not technically a seed oil.
Awesome. Well, last thing is and I think I asked this before, but just I think this would be a great way to conclude is, what are some good protocols or stacks? I know that's a term. I don't like that word, but that's a term that a lot of people like to use. Like, give us some protocols and stacks, if you will, for plasmalogens.
Start slow. Yeah. Depends upon your client, okay, or your patient, depending on who you are. So if you have a highly sensitive individual, someone with SIRS, ADHD, autism, or they're in an acute inflammatory state, you want to start with an omega-9. You want to start with low doses, okay? And this has been like, some people are really super sensitive. They'll respond to just a couple capsules of it, right? And so you go slow because you're gonna calm them down, and you're gonna open up some cells for them. So omega-9 is the place to start with there, and the mitochondrial stuff, like you can add them in as you can. And there's different supplements that historically are just super well tolerated, like your carnitines and acetylcysteines. So you can start with things that no one's going to have a problem with, and the curcuminoids that we use. And then once the system comes, so for really hypersensitized situations, you start slow, let them build up. Could be even a couple of months on the omega-9, okay, as you build up the dosages to ideally about a bottle a week. So you want to get to the 4 ml a day type stage. And then when they're in that, once you've kind of calmed the system down, then you can start incorporating the omega-3s in. So in these hypersensitized populations, you want to be very careful. Like ADHD, bipolar, you don't want to start hitting these people with a bunch of neuro off the bat, okay, of the omega-3, because it's gonna activate them. So for people like you and I that may be highly functioning, okay, you can get started pretty fast. Okay, or if someone has, ulcerative colitis, something that type of thing, like you can get them on high dose glia right away, like 10, half a bottle, 3/4 of a third of a bottle. And
how would you convert the mLs to capsules?
Each capsule is about half an ml.
Okay.
So 2 capsules per ml. And so, but most of us start with, so all of our employees, for example, they typically, and we're a young company, so most people kind of get to this happy medium of 6 to 8 of the glia, and in the same around 6 neurals in the morning as they get going. That's kind of the optimal level to really start rebuilding the brain. And if you really want to push it, someone like myself, okay, I basically go through a bottle of neuro and a bottle of glia, every couple of days. And so with the PC, and that's what. And I've been doing that for years. Yeah. So because I've looked at my brain scans over that course of time. So I didn't start there, because we did our clinical trial. Okay, the highest dose in the clinical trial was 4 ml, which would be 8 gel caps, and that's what gave us a statistical effect, actually. And so I started off with that dose the first time, right? And it had really good reducing inflammation on the MRI, and we had some movement. Then I started this, okay, then I'm going to jack it up a bit more. And then I got some effect, I jacked it up a bit more. And so, but the last interim on my MRIs, I went to the full dose that we use for our advanced diseases like Parkinson's, ALS, these MS at later stages, or late stage dementia. You really need to get up to, if you really want to reverse these things, you got to get the high doses and a comprehensive program. And the challenge then is not the biochemistry. The challenge is the support of that individual. Okay, like we can be our own eggheads and say, hey, here's the super exact biochemistry, but this person has got to go home, right? And they got to follow this instruction manual, and they got to get these pills out of a box and whatever it is, right? So we find, one of the biggest determiners of outcomes is really support at the client level, and we spend a lot of energy on the support side. But so as a stack, okay, the critical ones, get the omega-3 in the morning. Ideally, up to, you should be at about a bottle a week on those things. If you want to just get maintenance, and if you want to get higher, you're welcome to go higher. And then your bottle a week of the omega-3 in the morning, omega-3 at night, omega-9 at night. And then your basic mitochondrial support. And if you had to, prioritize, like the N-acetylcysteine, carnitine, CoQ10 combo twice a day is a big deal. Like that's standard, reduce brain inflammation, improve mitochondrial function. And then you can add your B vitamin mix to it. And I'm a proponent of relatively high doses. And the big one is niacin, good old-fashioned niacin. I know people get fancy with the NAD precursors and all that kind of stuff, but the old-fashioned, cheap as dirt, flushing kind. Get yourself up to a gram of niacin a day. I'm sorry, it is the most underrated dietary supplement out there. The data on reversing muscle myopathies, it's people just don't like the flush, but it's the triglyceride lowering, HDL elevating effect. It's a and you can't do the slow release, because it can cause cause liver issues, and so people try to, they just don't like the flush. But if you take our curcuminoid with it, you take it with a bit of food, if you really, there's some other tricks you can do, but typically you get tolerated. We have a pretty high success rate of getting people up to a gram a day, and so once you're up there, you're fine long term.
Awesome.
It's those are the kind of basic.
No, I love it. I know some people who listen to this later will just look for that little snippet of like, what should I do? But I do think understanding the why, which I think we really got into and probably could have gotten even more into, um, is super important because I think, I'm really excited about all the progress we're making in this field. And I think in particular, our ability to measure things at higher resolution. I think as we continue to unravel that, I think the importance of things like plasmalogens will continue to be more and more apparent. And I think more and more people will start to appreciate how these can be foundational parts of a health program. But thank you so much, Dr. Goodenowe, for joining me today. I really feel like we could have gone for another hour, but I know that you got lots of things to do today. But I'd love to do this again if you were open to it, and I really appreciate your time.
Oh, thank you so much, Anant. It's a passion of mine, and this is and it once you dig into once you get past a certain number of layers, it becomes fun. If it's fun to actually be able to do something, right? And then measure what you're doing, and you're not running blind anymore. And then you start seeing some effects, and then you say, okay, I'm moving the needle here, and now I can start adding some photobiomodulation to my record, like so that it's empowering, and it becomes fun. Otherwise, you're stuck with these, because often we often get the most difficult cases, right? And it can be a little bit depressing depending upon how much you can move the needle on everybody. And so it's invigorating to have systematic successes, and we're still just in the infancy of learning how to do more of this stuff. So
Wonderful. Well, thank you so much for joining me, Dr. Goodenow, once again, and thank you everyone who's listening. And I hope you guys have